So actually all that's left of module 2 is all that's left of module 2 is to do this exercise in detail, which we kind of talked over last time.
It's important that you show the title slide before you start. And if this happens for the third one, please edit it so that the slides are in the right order, because otherwise it's complicated. The Zoom won't work properly.
I see. So this is sequence types, and we just need to do these two exercises on this before we continue on to functions. So I just wanted to demonstrate what happens in this slide using code. Okay. So if L1 is equal to 1, 2, 3, and 4. Oops. And L2 is set equal to 1, 2, 5, and 6. And if we attempt this function, which we should not attempt, for E in L1, if E in L2, L1 dot remove E. So we'll attempt this. And presumably what this was attempting to do is to remove the files, remove the items from list 1 that are present in list 2. So at the end, we should have a list that consists of 3 and 4. But we actually end up with is a list of 2, 3, and 4. So why did that happen? It happened because if you iterate through it, so we can just talk through it. So first E is 1, and if E is in L2, we remove E from there. Then E becomes 2, and ideally, if E is in L2, it would remove E from L1. However, it skips ahead because the size of the list changes, because it goes from a list of 4 to a list of 3, and then it goes to the next item. So it goes from after that 1 is removed, it goes all the way to 3. And that's something that is an unintentional side effect of mutating list 1 while iterating through it. It changes the list length, but Python doesn't update the counter number. So the loop never sees element 2. So it's completely unintuitive, and that's why you have to be careful with adjusting these loops. So that's the take-home message there. As a workaround, you can use copies. So we can copy these over. And we set L1 copy to be L1 . And that will copy all of the elements from the start to the end of L1. And then we can iterate for E in L1 underscore copy if E in L2 L1 dot remove E. And now, even though we're removing from L1 copy is going to continue to have the same number of items, so there won't be that skipping problem. Okay, so here we have a name error that's often a mismatch in capitalization. So I have L1 capital C copy, so I can adjust that there. And when I run it, and then I check L1, and now I see it's 3 and 4 as intended. Okay, so as a quick exercise, let's spend 5 minutes on this and then we'll get to functions. Write a program that takes a list and returns 2 new lists where the input list values, with the input list values in sorted and reverse sorted order. So we're going to work off of list A, and we'll just give some values for that. And then let's have the end product have reverse list A, or sorted list A and reverse sorted list A. So spend like 3 minutes on that, and then we'll kind of show the answer and then move forward into functions.
We can go ahead and launch the progress poll here for people.
Okay. I think we have about a third who are still working through it. I'd like to talk through this solution, and we'll definitely give more time on the function section, because this is a little bit outside of what's directly used in CompuCell. So I think we'll be okay with this. But we have our list A. If we need to make a list that has its values sorted, we can make a copy of that list and then use the sorted dot method that we've mentioned previously to generate that. And then we can make a copy. And so this list A sorted is now in order. We can make a copy of that ordered list as list A with the list that we intend to reverse sort. And then we can use the reverse dot method there. List A sorted, list A reverse sorted. What I want to show you really quickly is what we would do if you don't remember what the command is for sorting and what the command is for reverse sorting. So you can go into Google. Yeah, so there's a comment that I've missed the capitalization there, so that would have thrown an error. And then there's a note from Sharon that it should be sort, not sorted, for the dot method. And what you would do if you can't remember what the dot methods are that you need, you go into the Python documentation. And you can just literally Google Python documentation. And then since we're working with lists, you can go into list. And you want the built-in type list, and then it'll have methods. So there will be examples of how to use these. There will often be methods, examples of how to use these. So let's go back up to the top. Lists, lists. Python built-in types. Okay. Sequence types, and then you can go into list. And then you can see that the method sort lists in place. So you can click on sort and it will show you examples of it. And so they've changed the documentation a little bit. From when I last looked. But the point is that you can find the examples. Yeah, and Sharon has great links in the that they have there. So what you'll find is, if we look, you'll find, as they pointed out in the chat, that sort is the intended, is the actual syntax and not sorted. So that will hopefully, that will then remind you to change the syntax there. And then you can run the command and see if it came out as you expect. So this is the original list. It hasn't been mutated. This is the list sorted from least to greatest. And then this is that list reversed from greatest to least. Okay, so with that, let's move to module 3, which is functions. So here is the title slide for that. Those are the links for the slide decks and stuff. And so what is a function in Python? So functions are used to create reusable pieces or chunks of code that can be run repeatedly. Functions are not run in a program until full screen mode. Okay. So functions are not actually run into the program until they're actually called or invoked, and we'll show you what that means in an example or two next. Then functions have certain characteristics. They have a name, they have input parameters, and then they have a docstring, which is an optional but recommended piece of information that shows you what how the function works. And then it has a body that is what gets executed, and then a return, which is what gets introduced back to the rest of the code outside of the function. So let's talk about that in place. So here's an example function. It has the keyword def, which stands for defined, and this is when a function gets defined. So it hasn't been called yet. Then the name is there. And then it has parentheses and input arguments or input parameters. And those are placeholder variables that will be used inside of the function to do commands. So they don't automatically have, it's not necessary, it's not strictly necessary that a function has an input argument, but any function that's doing anything sophisticated will use an input argument. Here we have a docstring that shows what the inputs are, and then what gets returned from the function, what the function does and what gets returned from the function. Here is the body of the function, just like in an if statement, if then statement, it is indented. Here in the body of this function, there is a print statement. Inside is even. And then there is an intention to return either true or false. Because remember, when you have a conditional, it evaluates as true or false. So I modulo 2 or I remainder after division by 2 is equal to 0. So if I is even, we're going to get a true there. And if I is false, we're going to get, or if I is odd, we're going to get a false there. So that's the function definition. To actually call the function, you call the name of the, you execute the name of the function, and you execute an input variable in the function. So let's show that along with inside the code environment that we want to work with. So I'm just going to open a new notebook in NanoHub, and we'll just make the same function. Def is underscore even. And then we'll have our input argument I. I hit enter after the colon and it automatically indents for me. Those 3 quotation marks indicate a multi-line string that doesn't get executed. It just has a space for notes. So what this is saying is we are asking that people who use this function provide I a positive number of type integer, so not a float, but a full positive number. And then we'll return so we're going to return true if I is even, otherwise we'll return false. So here's our print statement in the body. And the way the print statement is designed, it's just going to declare what's inside the function, that it's inside the function is even. And then we will have a return statement. Notice this is also in bold the same way def is, because those are keywords in Python. So that specification section, it's just 3 quotation marks in a row. And then you can end it with 3 quotation marks in a row. And those can be single quotes or double quotes. They just have to match. So this is the function. If I hit run, nothing actually comes out because this function has been stored in memory, but it hasn't actually been called. To actually use the function, we have to call isEven, which is the name, and then we have to provide an input argument that meets these criteria. So if we do 7, it prints inside is even, inside. Well, let's edit that. That was a typo. Okay. It prints inside the function is even. So it's demonstrating to us that the function has run, and then it outputs false because 7 is not an even number. Alternatively, if we run it with 8, we get inside is even and we get true. So one thing that to keep in mind with functions is something called variable scope. What happens inside the function and what happens outside the function can be a little bit different. So what I mean by that is, so we have this function is even, right? And we have this input argument I. If I specify out here, I equals 11, but then I run my function is even 6, and I hit enter, what do I expect to see? One might logically think that since I is equal to 11, we would get a return of false because 11 is not an even number. However, inside the function, I takes on whatever identity is provided, whatever value is provided here. So this value that we've provided here, in this case is 6, that takes on the identity of I inside the function, but outside the function, we get we retain that outside value. So because those are 2 different scopes. So outside the function is global scope and inside the function is local scope. Okay, so let's make that more clear. We're going to label So I've just edited this statement to say the value of I is I inside the function is even. So now I'm going to define the variable I outside once again as 11. And then I'm going to call the function is underscore even for. And then I'm going to do a print statement. The value of I is now, and then I'm going to print out the value of I. So inside the function, the value of I is 4. Inside the function is even. But outside the function, the value of I remains 11. So this is the difference between global scope and local scope. What happens inside that function, all the variable names inside that function only apply inside that function. So we can, if we define another function, so the question about why it didn't print true is because in the Jupyter notebook, true got returned, but it doesn't actually get printed unless it's the last displayed statement from the cell. So if you want to store the output of a function, you actually need to capture that variable. So we'll see that in a second. Let's see. So we'll do a simple function. Has an input argument of x. And we're going to return x squared. If this doesn't have a doc string, it should have a doc string. So we're going to add the doc string. So notice with one quotation mark, it doesn't work. You need 3 for a multi-line doc string. Okay. So if I call simple function 14, or let's do a number that we can easily multiply, simple function 14, and I run this, syntax error, where is my syntax error? Line 1. I missed the colon there. Okay. The value of x is 4 inside the function is even. If I try to access x out here, it doesn't actually exist. X only has a value inside that function, right? The other thing is, if I try to now work with that 16, it's not available to me. If I wanted to do x asterisk 2 minus 6, I'm also going to get the error, name x is not defined. So the best practice for when you call a function is to label, or is to assign that to that output to a value. Assign what gets returned to a value. And now I can look at x squared as 16, and I can do x squared minus 10. So because I misspelled squared. Okay, x squared minus 10, and I can execute it as 6. So when you run a function, you want to assign the outputs to a variable so you can continue to work with them in the global scope or global environment. This is another example that indicates variable scope, X has a value of 3 outside the function. Inside the function, X gets updated to a value of 4, but outside the function, it remains to having a value of 3. One warning, if there is no return statement, Python automatically returns the value of none. So you might see a function So now if you call that function squares 5, it will print 25 because it has a print statement in the function, but it doesn't have a return. So if you do z squared isn't going to be 25, it's going to be none, because there's no return statement to pass any value to z squared. The other thing that you should know about function outputs or function returns is that they're passed out in the form of a tuple. So if we do a quick function called area and volume, and then it has the input argument cell radius, pi r squared is how you get an area. So whereas the volume for thirds and I might have these formulas wrong, but it doesn't actually matter. And then I can return area and volume Let's go ahead and do the doc string for this sake of a good example. And then when we call the function, let's say the cell radius is 2.5. And if I print Z3, I get this. You might recognize this as a tuple. If I want to access individual parts of that tuple, I can through whatever variable I've assigned it to, Z30, Z31 will give me the second one. However, alternatively, what I can do is I can use what is called multiple assignment. So I know there's two values coming out of that function call. So if I provide two variables, they will each take on the value of one of them. So then I can print cell one area, and it's a good idea to use human interpretable variable names as much as possible when you're building these, because you're going to potentially be working with a large number of variables, and it'll just be easier to keep track of what they are. Then I can stay with human interpretable values all the way through. I don't think we need to do that at all. But we should talk about modules. So each Python file, each .py file, so this is a Jupyter notebook, but each Python file is what's called a module. You can define variables, functions, and types in a module and then access them somewhere else. So as we've talked about the complexity that emerges as you try to model a biological function. Imagine you're doing a model of cancer metastasis. You might have some model of angiogenic growth factor release. That is, you might have some code for that that's used both in the host tumor and in the potential metastasis sites. So you can import those you can import those functions or those objects to be used in multiple locations. So you can store that function for growth factor release in a Python file, and then you can import it into whatever file you're working in, so that you can save complexity by not having to have the large definitions in there. And that's actually what's been done in a lot of the libraries that we work with. So you've perhaps heard of NumPy. NumPy is a library that rapidly does a lot of the mathematical operations that we need in a sophisticated model. So you can import those as NumPy. So then if you have to calculate sine, cosine, all the way up to Fourier transformations and things like that, you can import them through here. And then once you do, you can access all of the available functions or variables in NumPy using dot notation. So NumPy dot FFT or whatever will become how you access the Fourier fast transformation from NumPy. You can see what's available in NumPy through dir or through the documentation externally. So here, dir shows us all of the built-in things in NumPy that could be useful. So you can see absolute value, you can see arcsine, arctangent. You can see there's a huge number of built-in methods and variables in NumPy that you don't have to code from scratch, and you can borrow from that way. You can also import it into the global namespace just by using, instead of using an alias, instead of using import NumPy as NP, you can import from NumPy import asterisk, and that would bring everything in there. But that's not necessarily a good idea, because you probably are not going to be familiar with everything that's named in here. And so the possibility of you accidentally overwriting one of them and then interrupting how a different one of these methods works within your program is likely. So far, we've done one-dimensional data structures. Lists, tuples, strings, these have all been linear. The next thing that we have to consider is labeled data structures. So previously we mused a little bit about collecting objects in lists. So we could have epithelial list, and that could have cell 1, cell 2, and so on and so forth. And then you could even store receptor levels, and you could store it based on order. You could store, receptor 1, cell 1 has 6 nanomolar of receptor A, and you could store receptor A levels in a list form for each of these, and receptor B levels in a list form for each of these. But as we've seen, these lists are mutable, and the index position can be adjusted. So what's actually a better way of doing it is to store the values that we want associated with each other with keys that connect them. So a dictionary is the first method that we will document to do that. So a simple dictionary called so just to illustrate it, we'll do sample dictionary equals, and then instead of brackets, we're going to use curly braces now. So that creates an empty dictionary, which we can call, and it shows that it's empty. And we can do grades dictionary. And the key, or the central structure of a dictionary is a key value pair. So in this case, it's the name of the person and the grade that they got. So now those two are located in grades dictionary. And if I want to access an individual, if I want to check for what Denise's grade is, I index it in a very similar way to that of lists, except for instead of providing an index position, I provide the key that I want. So if I want to find the grade for Denise, I use that key and I get the value A that's associated with it. So key 1, value 1, key 2, value 2, key 3, value 3, key 4, value 4. But again, you don't use those numbers. You actually have to access it based off of the keys. And the keys should be, again, human interpretable variable names. If a key isn't found, so if I go to my grades dictionary and I check for my grade, which hasn't been entered, I get key error body, meaning this key cannot be found in that dictionary. The way I can update dictionary is simply by assigning a value to a given key. So now when I look at grades dictionary, I see now it has 3 keys and 3 values. I can delete an entry through retrieving the key value pair, just like in a list. And now you can see that Anna is John and only these two entries remain. And then now I can check to see if that entry was in there. So if so Anna in Grade's dictionary false. Denise in Grade's dictionary is true. So to iterate over a dictionary, you must use either grades dot you must access either the keys or the values. So grades dict dot keys, grades dictionary dot keys, and that provides that. And if you look at, if you're confused about what type that is, you can enter that in there and you'll see that it's a specific type called dict keys, but that can be pushed into a list or a tuple. It acts like a tuple, but there's no guaranteed order. Actually, I think that was true in Python 2. I think there is a presumed order in Python 3, but it's still a good idea not to rely on that. And so it's against convention to use that. You can access the values through grades dictionary dot values, and that once again returns this tuple-like object. And then, as Sharon has pointed out in the chat, you can use multiple assignment to iterate over both of them. So for grades underscore dictionary, for K/V in grades underscore dictionary, you can do print K received V. Okay, so you actually have to do it with items on this. I've seen it. Yeah, so let's show what that looks like. Grades dict items returns these tuples of the list and dictionary form, and then you can unpack them using that multiple assignment principle to do something like this. So the values can be any type. They can be immutable or mutable, and they can also be duplicated. So if you look at our original dictionary, there were 2 individuals that had a B. That wasn't a problem. But the keys must be unique and the keys must be immutable. So keys can be integer, floats, strings, tuples, or Booleans. Strings are probably the most common. But the values can be anything. They can be lists, they can be objects, like user-defined objects that will come up later. They can be lists, they can even be other dictionaries. So list is an ordered sequence of elements. Indices have an order, index is an integer, and you look up elements by their integer index, whereas a dictionary matches keys to values, looks up one item by another item, no guaranteed order, but the key can be any immutable type. So instead of just being an index based on integer, the key can be any immutable type. So again, we showed how you can manually create a dictionary through the use of curly braces. And then you can add to a dictionary by assigning a key value pair. We could also create a dictionary systematically through a function. So if we take a look at this function, let's type it in here. So this function has the key, has the name lyrics to frequencies and has an input argument lyrics. Inside this function, there is a empty dictionary named my dictionary. And then for word in lyrics, so lyrics is some kind of collection, potentially a list. For word in lyrics, if word in my dictionary word plus equals 1. Else so if you have a list of lyrics, for each word in lyrics, if the word is in the dictionary, we're going to increase the value associated with that word key with by 1. If it's not, we're going to add a key to that dictionary based on that word, and we're going to set that equal to 1. So let's create a test case. So now let's take a look at lyrics. So lyrics has just a bunch of letters in it, but you can iterate over, but this would still work the same. So now let's call the function. And we're not going to get an output. So why did we not get it? Name lyrics to frequencies is not defined. Okay, so we never ran this cell after writing it. So now we'll run this and we still didn't get an output. If I check for my dictionary, it's going to say it's never been defined. So why is that? This goes back to what we talked about at the beginning of this lesson. So the reason is my dictionary was only defined inside of this function, and it does not exist outside this function, and there's no return statement. So now we should modify this function to return my dictionary. And then we should also assign the returned variable to a variable in the global namespace. So we'll call it counted words equals lyrics to frequencies with lyrics in there. So let's run this. So that's been updated. Now let's run this. And now let's check out counted words. So there were 5 A's, 5 E's, 1 G, 1 S, 3 F's, 2 O's, and then 1 I and 1 J. Any questions about that? Okay, I don't see any questions at this point. You can do a similar function for most common words with the same kind of idea. If you have an input argument that's a dictionary, you can check the values of that dictionary and assign them to a values, and then find the maximum value, the highest value. So we can take counted words. So, okay, so let's copy in this whole function. Since we're copying into PowerPoint, we're going to have to do some syntax fixes. Okay. So a couple of things I want to point out here. One, how did I know where that return statement would go? Typically, the return statement will be when you want the function to be over. There are some situations where it's inside of a branch, but most often it'll be at the end of the function and it'll be at the highest level of the return statement. So what's being returned is words in best. So if we take, so if frequencies is a dictionary, such as counted words, so counted words is a dictionary. If we take counted words and enter it into this place of frequencies as our input argument, it's going to take the values from frequencies and set it as the variable values. It's going to take the highest number of those values, which in this case is 5, and it's going to set that as best. And then it's going to create an empty list called words for K in frequencies. So for each key in this dictionary, if that key is equal to best, it will add that word to the list. It'll add that word to the list. It'll add that key to the list words, and then we'll return words in best. So this is a function to find the most common word. So and then again, we want to use human interpretable values here. So the first one is going to be words, which is list of most common word. And the second one is going to be best, which is going to be the most valuable, or the max value. So and then we can print those two values. Print so there were two most common words, A and E. So that actually matches that output up there, right? Any questions at this point? It may have been a little bit fast. So we're kind of integrating what we learned about how to set up a function with what we've learned about the structure of dictionaries. Okay. Well, we can leverage the properties of dictionary. So let's take a look at this alternative function that we have here. Okay. So words often, it's going to take in an input argument frequencies, freaks, which was presumably there's no difference between, so there's a question, how would this have worked? Could this have worked if it was for a K and freak? So let's just do that. Okay. For K in freaks, print K. Freaks is not defined. Freaks is counted words. Okay. Freaks, the variable freaks only exists inside that function. So outside that function, the dictionary is counted words. And then for encountered words dot keys, it's the exact same. Okay, so if we take a look at this function, so we remember frequencies is dictionaries, is that dictionary that we've been working with as that input argument, but min times we're not sure what it is. It's being compared to something, so we can build off of that. But anyway, so result equals an empty list and done equals false. While not done, meaning while done still equals false. No, while not done, meaning if done is false, while true, while done remains false, temp equals most common word frequency. So most common words is this dictionary, this function, and these outputs. It's going to call, so this function is calling that function. So you can have these nested functions. If temp sub 1, so temp is the outputs of this function, which is these two returned variables in a tuple. So temp index 1, which means best, which was, if you recall, there, the most common word, the frequency of the most common word. If that 5 is greater than or equal to min times, then we're going to add temp to result. And if not, we won't. For W in temp 0, for a word in, so for the word in temp 0, we're going to delete that word from this dictionary. And then at the end, when done is equal to true, we'll stop and then we'll return the result. So this is directly mutating the dictionary to make it easier to iterate. So this is a little bit complicated, but basically what's happening is we're calling this function and we're putting the most common frequency into a result. and then we're deleting that key from this dictionary, and then we're going to run that function again. Then we'll find the next most common word, and then we will update our result, and then we will delete that next most common item from this dictionary, and then continue on. And then we're going to basically create a list of how frequent. What you're going to end up with is a list in order of how frequent these results are. So to see that in action, we can do it. We can just throw a print on there, words, often. Counted words, and we'll do 3. So one thing I didn't mention is this will only happen if it's greater than or equal to min time. So what this is going to do is this is going to create a list. It's going to create a list of the most common words. It's going to create a list of tuples of the most common words that appear more frequently than this minimum times. So let's take a look at how this goes. So yeah, so it said, though it's the most common characters that appear at least as many times as minimum time. So AE5 and then F3. Are there other questions about how that works? Maybe take a minute to look through that. Okay, so what I'm going to suggest is it's 3:57. We're going to go to 4:05. Take a look at, make sure you understand how this works, how these two work together. How these two work together, and take a stab at this exercise here. So 3:57, let's go to a 4:05. So min times is just a number, and it's going to be the minimum number of times that you want. So in this case, when we entered 3, it basically collected all of the possible most common words and frequencies that occurred more than 3 times. So if you entered 2, it would include AE5, F3, and O2. So again, that's also why it would be beneficial to have that doc string. But if I put in a doc string, you're not going to be able to see both of these at the same time. So we'll put in a doc string after at 4:05. I mean, there is a way to do it, but I don't think there's a built-in way to do it. You can do a list comprehension. Yeah, we can do that. Yeah. Okay. So I want to start because this, I recognize it's a little complicated. I want to start by commenting out every line for these. So input is a list and returns a dictionary input a list, returns a dictionary that has with keys of the items in the list and values as the frequency of those items. Okay. And then we'll go down here. The input is a dictionary of with keys as words. In our case, we're using characters, but words, and values are the frequency of those. And again, those are coming from that original list of well, it wouldn't make a difference if the input was a list or a string. I used lyric string and then I converted that to a list there. But it would work the same for a character, for a string or a list. But anyway, at that point, is a dictionary with keys as words and the values of the frequency of those keys. And the output and the return a list of the most frequent words or characters, depending on what you entered, and the frequency or the count right? So here we've extracted the values from the dictionary. Best is the highest value of the dictionary. For each key in the dictionary, checks to see if that key is the highest, has the highest value. Right? Because it's checking to see if the value associated with that key is equal to the max value. Adds the max, adds the key with the highest values to words. And technically, this is the key with the value equal to the highest values because it can be more than one. And then returns a list of most frequent words and a value and their count. So it returned that and that. Now, here we have an input argument of that's a dictionary of words and their count as before, and then a threshold for how for the minimum count to keep. And then the output is result, which is a list of tuples of most frequent words and their counts. So empty list creates a holding variable, a temporary variable. It's going to taking this output, right? Most common words is this function. So it's whatever the return of this function is, a list of the most frequent words and the count of those words. Temp is a list of most frequent words and their count. It's actually a list of or it's actually a tuple. And then what we do here is we check if is the count of the most common word greater than our threshold min times. So it's checking to see if the most common word that came out of here, is it greater than or equal to our threshold of min times? If it is, it's going to append not just the count, but the tuple. Appends tuple of most common word and count. So I'll just put it in tuple form just to show you. So it's a list of most common words and their count. It's going to append that tuple to result. And then it will delete that word it's going to delete that word from freaks, that word and count from freaks. And it will continue to do this until it's created, until it returns a list of tuples of words and counts that are above the min times threshold. And that's how you end up with this. Okay, I'd be happy to go over that with anyone in our next break. So now we have this exercise of character counting. We're write a function that returns a dictionary with the number of occurrences of each character in a string. So it's actually very similar to what we've done so far. So let's take a string like that to have in our head. So the input is we'll just call the function character counting. The input is going to be input string. It's called instr. So it's going to return a dictionary. So let's create an empty dictionary called return dictionary. Now we can iterate through each one of these. For car in str. So for the character in the input string, we want to add that to the dictionary. Return dictionary car equals 1, right? But what if it's already in there? If it's already in there, we need to increase the value by 1. If it's not in there yet, then we need it to be 1. And if it's already in there, we need to increase it by 1. So we have to check if car in return dictionary will increase the count by 1. And if it's not, which is our else, we'll set it equal to 1. And then we'll just return dictionary. So we can just throw a print around the return statement since we're not going to need to use this for anything. Car accounting, let's see if it works. Car accounting, S2. Yeah, 3 U's, 3 H's, 4 U's, 4 Y's, 6 T's, etc. Okay. All right, that's the end of that module. So there's going to be a questionnaire, and then I believe we're going to start the next one at 4:35, just to give you guys a 10-minute break. And I think the next one is the last one. Is that right?
Yes, that's the last module for today, and then we'll have a short Q&A session at the end.
One thing I want to just mention is that for people who are new to Python, this is basically a semester's worth of Python 101 at Michigan in about 5 hours. So it's not necessarily expected that you will have internalized this. What our hope is and our expectation is that seeing all of this material will prime you to understand what you see or what you use in the different models that are demonstrated over the course of the week.